Okay, welcome. Query string parser. Mike, you're into parsers, right? So this is like right up your alley.
Indeed, yes.
Okay.
Parsing is fun.
I'm glad you think so. You know, it takes people like you to make the world go round, because I am just like not smart enough to do this kind of stuff, and I get very intimidated anytime the word parsing comes up. I want to go into my little shell and just hide. But I very much admire people who are not afraid in the way that I am. Anyway, it says you're required to implement a type level parser to parse URL query strings into object literal types. So some requirements. We'll see it in the test, but this looks decent to read. So value of a key in query string can be ignored, but still be parsed to true. For example, key is without value, so the parser result is key : true. Okay, makes sense because it's like presence. Duplicate keys must be merged into one. If there are different values with the same key, the values must be merged into a tuple type. That will be hard, but all right. When a key has only one value, that value can't be wrapped into a tuple type. Also makes sense, so you can't just use tuples everywhere. If values with the same key appear more than once, it must be treated as once. For example, key equals value and key equals value must be treated as key equal value only. Wow. All right.
Yeah, this one is intense.
This is like really tough stuff. I can okay. So
yeah, I am interested. I do have a initial approach I'd like to run by you. Yes. So when I see problems with this amount of complexity, I immediately think, okay, what are some more functional programming paradigms we can use to approach this? The immediate sort of element I want here is a split by operator. So I want a split by operator so I can split on the ampersand character. That way, then I'll have a tuple of these k1 equals v1 elements, right? Then I want to, those are going to be, I can do another split by if I wanted, and then I have like this tuple of like key value pairs. Mm-hmm. And then I want to loop through that tuple and build up a object as like an accumulator loop.
Mm-hmm.
Yeah, and
I'm taking notes. Yeah, all right.
Yeah, and I think at that point we will essentially have a solution.
There inside the accumulator loop, we'll be able to specify what the behavior is, like how to do merging and stuff like that, right?
Yeah, I think so. I may want to have a pre-step actually to first go through that tuple and identify the tuple elements that have duplicate keys. So then I can basically simplify that tuple into one that already has performed the step of converting the values of duplicate keys into like tuple elements, if you know what I mean.
I know what you mean. Okay. I have good news. So I think well, if you'd like to try it, I won't stop you. But I'm looking through some of the solutions that Mike, you're so eager. Okay, you want to try it?
Yeah. If you don't think it'll be a waste of time, the
how about this?
Yeah,
I'll give you some helpers like this one.
Yeah, right.
There's nothing spicy in this. This is exactly what I think, like probably character for character, what you would have typed.
No, I'll make the modifications I want to make.
Make some mods. Okay, make some mods. Oh, because you want to make it
yeah, I want to make it generic.
Okay, it's always going to be the same thing, but that's all right.
I know, just yeah, for aesthetic's sake.
All right, fine.
Okay,
but this is close, right?
Yes, that's close. I'll rename it because I think it's just a generic split operation. Like it has nothing to do with this problem. It's just a type level split operation. It makes it easier for me to think about.
Now it is. Yeah, now that you added your thing. All right, wonderful. Yes. What would you do next?
Yes. So next, basically, I'm going to let's start building it out. So this is going to be the parse query string. Immediately, I'm going to kind of build this out and build out some temporary type variables. So I'm going to say split by and I guess not a super good name, but I'm going to say this. I'm going to split T based on, let's find my ampersand character. Okay. And then this is actually going to be a string.
Yeah, I got you.
Okay. And then let's kind of just test this out. First of all, I'm going to make my own little test bed, and I'll copy one of the examples.
I mean, I'm just gonna.
I could have. Yeah.
Do this.
We can. We can do that.
It's easier to see them on screen.
Yeah, I don't see those on my screen.
Oh, you don't? Oh,
I don't. Yeah.
I'm sorry. You have to have the extension in your live share. Well.
Oh yeah, I should have set that up.
Oh well.
Okay.
So did I do something wrong? Oh wait, there's a. Okay.
Okay, and I will down here, just so I know which one I'm looking at, I'm going to do that. Okay, so yeah, so this successfully splits it. So now I kind of want to just split it again. Usually I would do some sort of like mapping operation, but this one doesn't make it super easy. So I'm just going to say type sort of split. This is going to be the split params. So this is going to be string, and then say first split equals split T and then I'm going to say equals, and then we're just going to loop over each of these elements and split them. So this is going to be K in key of first split of K, and then I'm going to split each of these by equal sign.
Oh wow, what a strong case you've just made for making it general purpose.
Exactly.
yeah. Wow. Okay.
Yeah, and then this, it seems to not be convinced that it's going to be a string, which is fine because sends U, T, U, and unless I do have something legitimately incorrect here, I can say. All right. And then I'm going to use my own like split params operation instead. And what do we get for a result? Yeah, we get what we expect. Okay, great. So now we have this kind of thing split out in a way we can understand it. And now I want to identify the keys that are common across this tuple. So essentially, I want to, well, we have a bit of a branching path here. I can either do this in like a pre-processing way, and assign everything to, for example, like, well, no, actually, no. I know how to do this. So we're just going to loop through the,
yes.
I'm going to say K in split by end. For this, I'm just going to say key value pairs. That's a little bit more semantically accurate. And I'm going to even say that this is going to be the type level is not smart enough to actually know that that's going to be the result of split param, so I'm going to disregard that. And then I'm going to say key of here, and this is just going to be an identity operation for now. Okay, so I'm looping over each of these pairs, and I want a accumulator, and I want that accumulator to be a sort of generic object like this that starts out as empty. And I want to loop over myself actually. So this is not the way I want to loop. I actually need to do a recursive loop. So that's instead going to be key value pairs extends infer head for tail?
Yep.
If so, I'm going to process string. I'm going to call that on
okay.
tail.
Yep.
And then this is actually just going to go down because this can be calculated each time. And then this is going to take the accumulator, and then that can be done like this. And then I need to process head, but before I do that, I'll define the base case, which is going to be the accumulator. Tail, it's not convinced that tail is going to be a...
we can do it in here, right?
There's reasons that are hard to explain. I avoid doing it in there.
Why? Wait, explain it to me. I want to know.
Yeah, it is. It leads to performance issues.
Really?
When you're doing like very large, when you're trying to handle very large input, that is what I've seen.
I think it just wants it to be above.
No, it's saying tail needs to be
string.
A parse query string. Oh yeah. This is because I'm doing it incorrectly. This gets unmodified. And then what I'm actually doing is I'm passing. So I got it wrong. This actually should be the second parameter.
Oh, okay. All right.
And then we are, this is going to be where tail lives. And then it's happy. Okay. So if I look over the result now, we get empty array because I'm not doing any transforms. So now I'm going to say, very simple. I always get kind of trip up over making object literals from key value pairs. I want to say that this would be head of 0, but that doesn't really work. I don't think. And then this would be head of 1. So let's see.
I don't think you can. That's a syntax error, isn't it?
I don't think this is syntactically allowed. KN. So I mean, this might be just a matter of casting, honestly. So.
Oops.
And then. Yeah, and then it's saying head is not necessarily going to be something that can be indexed. So, it might be gross, but that's what we're going to do.
Once you start casting, you can't stop. It's just like it starts. It's like a poison. All right.
Okay. Let's see.
Working. Doing something.
For the result we have defined above. Yeah, so then we just need to intersect it with the accumulator. I forget if this is permissible TypeScript syntax.
Media key system access.
Oh yeah,
that's the second time. No, it's not. You can't spread like that.
But
so
I
you
can
have to. Yeah, exactly. You have to rock with the.
Okay, so now it's actually saying that the intersection results in never. This is understandable. It's because we're not really handling the duplicate cases properly. So arguably we have to check whether accumulator already contains a value. Yeah, already contains the cast 0. So here's the kind of the check we need to make. So we're going to say, does key of ACK extend this ? If so, I'm going to do nothing, and elsewise, I'm going to do this.
All right.
Yeah, it's getting a little complicated.
Oh. Yeah.
And then what is it actually saying?
Okay, let me try to make sense of this for me. Okay, key of there. No syntax errors. Okay, let's go down and look. Empty object. But
empty object, which is not great. And I think that's because the subtype, I got the order of the subtypes wrong.
K1 V2? Okay.
Okay, V1, V2. So looking at the inputs, we are testing on A13. K1, V2. Okay, yeah. I'm declaring bankruptcy on
Great. Thank you. Oh my God. You're like, oh, that's good. I'm really I'm over my head myself.
Yes.
Okay, we'll save all this though, because we might come back and look at it. I'll show you one by Yinks, not Yinks Meta, MajorLift. Man, I copied everything but his name. Okay, let's put it here. So this is Young Sung. He's been on the, I think you've talked with him on the Michigan TypeScript Discord. He does great work, and I always love his solutions, and he has a great one for this. So that's where I pulled the split params from. So let's look, you direct me through it, because you understand this better than I do. So
all right, we're immediately saying, just to edge case, if T happens to be empty string, we're just going to return nothing. That's fine. So then we're splitting params into the form whereby
the little different than yours.
Yeah, indeed. And then we're passing that tuple into merge params, which seems to be a accumulator strategy, as we discussed before. Completely tail call optimized, which I like. And we are looping on a per tuple element basis on line 154.
Yep.
We're inferring the underlying structure of the key value pairs, which is nice. Instead of splitting again, we're merely doing a inference. Then we're calling merge params on a set property field. I think this is kind of the issue we were running into before on doing object assignment on the type level is actually more tricky than you would expect. And then we're saying if it's not the case that it is a key value pair, then if it's just another string, we are setting a property. So this is interesting. It seems as a part of the input, we can just obtain key values on their own. What is the semantic meaning of this again?
It should be Boolean true.
I see. Okay, so that's just a edge case to check that.
Exactly.
Diving into set property.
Yeah.
This
set property is the end.
So this one is merely, I think this is a decision tree, essentially, deciding whether we should convert what we already have into a tuple if necessary. So we're saying we're looping over all of the keys.
Why do you think this is there, the or K?
Oh
thing?
Yeah,
because
that's totally
recursion. There's no recursion here.
I don't think it's recursion. So this is notably to how to read this. This is key of T or K. So what we're doing, we've seen this in prior challenges.
Oh, is it like that? No.
No.
It's not.
No. It's key of T and then separately or K. So what we get is the set of things to loop over. Like
this.
Yeah, exactly. So the reason we can't just loop over the elements of T, which is M, our accumulator, is because we are going to be adding new things to it. We need to loop over both what currently exists and what is going to exist. And K represents what is going to exist.
Oh, K is past. Okay, but K is not just some random thing. K is the K. Oh, K is the keys.
Yeah, exactly.
Okay, and V is the values. Okay, all right.
Yeah, which is going to be a single key, right? So this is where I think it can make it more readable if we go away from the single letter type level variables and we say key to write or something, or we both tried to do it, I think.
Oh, sorry.
Key to write or key to set, perhaps. So it's very explicit that this is the key we're using that we want to set on.
Yep.
And there's only going to be one key. So it's not like a union of strings. We can just assume it's a string.
Yep.
Same thing with the value. And then, the decision tree logic, we can go into it. We are sort of asking, is P the element that we're trying to set? If so, we have a bunch of this logic. Otherwise, so if it's not the value we're trying to set, notably, we ask, is it a element of T itself? Then we're just going to perform the identity operation. So we're not changing it at all.
I see. So on line 172, we're like smushing key of T and keys to set together, but then immediately we pull them apart again.
Yeah. So it's and the reason why we are doing this is because we need to loop over everything because we don't want to use a intersection operator. The reason we don't want to use an intersection operator is that it won't work and it will result in never. This allows us to like truly overwrite keys that already exist. And then it's never going to be the case that P is something that's not a key of T or key to set. So in that case, we just return never down below.
Oh, okay. All right. Yeah. All right. Yep. So
then,
we don't have to think about it.
So then we're performing the logic. Okay, does a duplicate key exist? If so, we just perform a lot of like almost the business logic that is encoded in the requirements. So duplicate KV pair. This one, trying to parse it. So if it's duplicates, we don't do anything, it seems.
Yes. That was another requirement. If it's somebody passes exactly the same thing twice, then you pretend they passed it once. Don't add. The idea is because when we have multiple values for duplicate keys, we want to return a tuple. But when we just have one value, we want to return just the value. But if the values are the same, we don't record a tuple with two things next to each other that are the same. We treat it as though it's one.
Okay. I would almost say that what we're trying to say, so this is kind of inconsistent because if you have, we're not encoding it as a set because we could have look at
A3.
K1, K1 and K1 is just going to be true rather than, but if we say and K1 equals V1 and K1, this is an interesting case to me because is the behavior, it should be, it seems like the behavior in this case should be like true V comma V1 comma true.
I see what you mean.
I don't know. It is merely an interesting set of requirements. But going back down here, if its existing value is a tuple, then so this actually, no, my question is answered. This is encoding set logic. So by definition, the tuple cannot have duplicate values.
Yes.
Okay. Yes. So that's what this is encoding. And then finally, if we have a new value, but the original value is not a tuple, we need to convert it into a tuple. And that's it.
Just like that.
Yeah.
Yep. Just like that. I think this is a great solution. Very clean solution.
Yes.
What do you think?
Yeah, I think this is a great solution as well. Yeah.
We'll see how it stacks up against the competition. So we have another one here from drylint. So let's just go from here. So we handle our that edge case again, same one that Youngsung handled. We're splitting out the head and tail, like getting those pairs. That's not handled with a helper, but basically the same kind of thing. And then we're recursing at that level, passing in an object that we're building up. Now the object doesn't exist the first time through, so that's how we can be sure that, that's going to happen. I think this one might get tripped. In fact, I don't think any of the tests have like a escaping system for how to deal with literal ampersand being in there. So I think we can thank our lucky stars that didn't happen. And then we're splitting out from the actual elements, and then we do the merging logic. We're seeing if that, it kind of reads, but from the accumulator, we're emitting K, which is the current value. But also intersected with, and then we're taking that omitted thing, like we've kind of cleansed it of the K, and then we're adding back in this get value thing. So let's take a look at get value. So here in get value, it's much tighter because there are no comments, but it's basically the same decision tree logic that you were just saying. Like, at this point we return just the literal value. This is us adding to existing values that may have already been there. This is there. This would be so this is like the first time through. This is the second time through, and here's the third time through if we have more values than 2.
Yeah. I actually like I like this get value thing. I think there is a potential synthesis of these two approaches that would be eminently readable and approachable. Notably, this get value is not handling the logic of actually writing to the object. Instead, what we do is we create a simple object down here that has only the element that we're talking about, and then we remove that element from the original. From the original, so that there isn't a conflict that causes never type to exist. But it's sort of that removal logic is kind of messy, as we have to like loop over all of the keys. I could go back and forth on whether it's certainly elegant in that it uses a lot of the built-in TypeScript types.
Yeah, it's nice. I don't think it's as readable personally. Despite the MajorLift one having a bunch of variables or having a bunch of comments and having a bunch of stuff to read through, at least you can read through it and understand it. Not that you can't. It's fine. It's a good solution. Better than I could do, that's for sure. But here's the third one. This one is by justBadProgrammer. We've seen them many times before in the challenges. They have an includes helper. Includes is its own challenge. Merge is just there for the equals type to work. Merged query object is where I think we start to get into new things. So let's just look from here. So parse query string on line 283. Again, we have our edge case being handled. We're splitting out the different elements. Do you have to say extend string? No, you don't have to say extend string because we're in a string. That works. And then we do the same thing. We grab. So we're seeing kind of a pattern here. You split up one level, and then you split up the next level.
Yep.
And this is handling the Boolean case. So if there's, with handling just if there's one. Maybe I don't think we need this. We could probably get rid of this whole thing.
Maybe.
Anyway, never. I bet you we can't. Anyway, no, that's all right. It's very similar.
Yes.
You see here, like this stuff is exactly the same. This stuff is exactly the same. There's a way to refactor it out, I think. But anyway, we'll leave it. Then we recurse at that level, passing in u. So u, notably, is the rest of the string. It's like the next element after the and. So we're kind of going through piece by piece like that, separated on the ands. And then we have create query object. That and the combination of update query object is where the magic happens. So Mike, what do you think about these two things, create query object?
Yeah, so looking at this, we're sort of deciding to update or merge depending on if it already exists or not. I think that looking at both of these, I think there is a potential case where we're doing both of them, but I don't know. I kind of like the aspect where we are sort of routing what we want to do based on whether that key already exists or not. I think that makes it more readable than the decision tree that we saw earlier.
Yeah, I mean, we do still have some. So like there is the ugliness has to exist somewhere because there's a lot of like product requirements for this type, if you want to think of it that way. So that's been locked away in update query object.
Yeah. It is interesting. This includes the fact that we're performing that sort of set logic by just checking, hey, is this value already included? If so, we add it. If not, we don't add it. Another approach would have been to use yet another like sort of prior type challenge solution, which would be unique. So one solution is just you always add it, and then you run everything through like a uniqueness pass at the end.
Yeah, and for anybody to see, like here's an implementation right above us for unique. We actually already have includes. So if you look at them side by side, I don't know if I can fit them on the screen, but in any case, if you look at them side by side, you'll see that sort of is what's here. Sort of.
Oh, yeah, exactly. So we could merely, I believe what we could do is, as I said, just kind of replace, but it should still work, yes.
Works. And then we don't need, I guess we don't have this. Does that work? Yeah.
Yeah.
Okie dokie.
So even a simpler case, we're just checking if it's a tuple, right? So really, we just check if it's a tuple rather than destructuring.
Yeah. Yep, that's a refactor call. That's so funny you caught that. I'm like, oh yeah, that looks fine. And now I'm looking at it like, this is terrible. But that's how some of the worst code gets created. It's like missed in a refactor, and it doesn't make any sense now, but it made sense once upon a time.
Yeah, one thing I think would be interesting is like a VS Code extension for type level, like TypeScript type level logic that like automatically finds things like that and auto replaces them. Like does syntactic simplifications that are like equivalent in a way that you can be very sure about.
Have you heard of ESLint? I'm just kidding.
Yeah, I don't know if ESLint has like type level operations like that.
Yeah, definitely. It has type level refactors and stuff. Sure. Yeah.
Oh yeah.
You can even sort. You can even have it sort your union members.
Oh no.
So yeah, cool. Well, I think that one is the last one. Haven't we tried hard enough? That's query parsing. Which one? So wrapping it up, which one did you like the best?
Oh yes. This second one I'm very intrigued. I mean, the first one is very readable.
Yeah, MajorLift.
I am intrigued. Yeah, MajorLifts. I really like this one. If we visit the second one really quick, there is something I was wondering.
Okay, drylint.
Which is here. Is there a potential extraction that can be performed to get this in a state where these lines are not being almost duplicated? I'm not sure.
I would say no, because it's this thing. This is the problem, is that like we're creating a value that didn't otherwise exist. Like true was never specified. Here, I'll delete everything else. We can try.
Yeah. I want to try because I've done. Okay.
Drylint. Did I delete the right one? Okay.
Let's see.
There's a lot of code on the screen. How about now? Is it still there?
Yeah, this is, I think there's some extra stuff from the prior one.
Unique is here.
Let me see where we are. No, this is not the one I wanted.
Oh, I'm sorry. Okay. justBadProgrammer. You wanted, okay, not MajorLift. This is the least entertaining television ever. Drylint. Okay, good. You wanted drylints. Okay, now it's good. Now we're there.
Yeah,
yep, this is the right one. Okay.
Yeah, so here's what I want to do. So the places in which this differs, I'm going to add this check inside. So I'm kind of doing like a inversion of the syntax. So K here, I'm going to say, does T extend all of this? And we can like refactor this. If so, K. Otherwise, I believe what we're passing in is T.
Yep.
Yes. And then kind of, do you want to give this a shot at being the linter?
Yeah, definitely. it's something I can do actually. We'll just comment that out, and then we'll put a merge there. For everyone watching at home, there is no good way to do this. That's what I'm convinced of. Like, I've thought many times, like, I've developed my own little style for the challenges, and I thought, like, oh, is there a way this could be implemented with tooling? And it's like, it's just so situation dependent. Okay, so like here, we're getting closer to something readable. Okay.
Yes. And then in the prior thing, we're saying K was here, but instead it was T before. So I'm also going to just insert this here, and I'm going to say, we were seeing maybe the fact that this is not wise. K, otherwise T.
And then this was going to be accumulator of T and true. No. Sorry. I suck. 1 second. We need both. We need to do it a third time.
Yeah, exactly. So,
I mean, let's do it, and then let's see how it looks.
Yeah.
So there's that, and then I'm like way off in La La Land, but that's okay. And then here, all tests pass. Okay. So.
Probably not good. It's one of those things where it's almost too, like, you factor it in one way, and it gets unfactored in a different way.
Yeah.
In these situations, I am convinced there is okay, actually, here we go. So essentially what we're saying is we want to arguably, I would want to make these, where does T come from? T, we get T, so I could say, I think in this case, so we can do this. So there is a common element. I'm just going to say, I don't know what to call it, so I'm just going to say meta for now. And then I will replace all instances of this like this, because it's a common...
Wait, one at a time. Well, hold on. We got an error.
Okay. Oh, sure.
Up. So meta is not, it's not a property key. Okay. Does that work? Okay, now we're good. See. Yeah, replace it. Okay, great. Next.
Yeah, meta.
Okay.
So that simplifies it a little bit, right?
Can we put meta here?
Then, no, that wouldn't work.
Oh, right. Yeah. No, we could put it in here. So we could do this. No?
Yeah, what happens? Why does it fail?
Meta cannot be used to index accumulator. Extends. Okay. How about now? Aha!
All right, great.
Okay.
And so it's kind of a little simpler. And then we should be able to remove this final source, this final 111 thing by basically saying a second variable, which is...
Is that really better?
Yeah, good question. Maybe
that's not better, because we're only using it in that one place, and at least you can see.
That's true. Yeah. Yeah, your mileage may vary. We don't need... Meta is bad. A bad name. What is this semantically? Some sort of key, I reckon.
Yeah, we don't need V there. What is meta? Oh, you're asking the deep questions. I don't know.
Yeah. I think if we have a good name for it, this becomes much more useful. So thinking about it, it's either the actual key, or it is the value, right? Or no. This is the specific. This is always the key, because if it's T, this is the case where it's like a standalone key. You know what I mean? So this is the key to assign. You know what I mean? Because in the case of T, this is just
right.
checking. Yeah.
Okay. Yeah, I get it. I get it. Yeah, because it could be a duplicate, it maybe not, but this is like the one we want to use. Okay.
Exactly. Yeah. Or no, not that it's a duplicate, just in that it could be of the form like K1 instead of.
Oops, sorry.
Yeah. K1 versus like K1 equals V1. Right?
I screwed something up here. I'm sorry.
No. We can just undo.
Well, can we though? I'm doing it. 1 second. Oh, key to assign. I put meta in there. Okay. Because I don't. Yeah. All right. Well.
Yeah. We're way over time, probably.
Yeah, way over. Well, that's how it is. If people are not watching by now, they've tuned out long ago. So, thank you for everyone who is still watching. I hope this is interesting to you. Let me know if this kind of like, have you seen Community, Mike?
I don't think so.
The TV show. It's like a Dan Harmon show. There's these two characters, and they're just. It's not going to be funny to you, but anyway, if you haven't seen it, but there's these two characters who are just like. They have like a morning show, and I don't know. That's what this felt like. This just felt like a morning. Yeah. If there were like a TypeScript morning show, and we're like, oh, like come on, it's like we're cooking. We're doing live cooking. That's what it feels like. Okay. Anyway, bye everyone.